Welcome back to Lesson 2. As we did with the addition of mixed numbers symbolically, we will use two methods when subtracting mixed numbers symbolically. Videos 2 and 3 of this lesson will focus on Method 1. As we work through the Method 1 process, we will only be using numbers and symbols to complete the subtraction calculation. These are just a couple of little red flags, not to scare you, but just to warn you that what we're about to do, you better be paying close attention. We're certainly not putting up white flags. We're not surrendering here. For Method 1, we will, first of all, rewrite the mixed numbers so that the proper fractions of the mixed numbers have a common denominator. We will then check to see if the proper fraction of the first mixed number, the minuend, is greater than or less than the proper fraction of the second mixed number, the subtrahend. And this will give rise to a couple of situations. And in this video, we're just going to be looking at situation A. So if our proper fraction of the first mixed number is greater than the proper fraction of the second mixed number, here's what we do. We subtract the whole number portions of the mixed numbers. We subtract the proper fractions. We then combine the resulting proper fraction with the whole number. That's where our focus will be for this particular video. Now, I've also put up the situation B, but we're not going to discuss that until the next video. Of course, we always check for simplest form. I assure you, this process will become clearer after we look at a few examples. So let's see how this works. Subtract the following. In A, 4 and 5, 6, subtract 2 and 4, 6. The first step in our process was to write the proper fractions with a common denominator. Well, 5 over 6, 4 over 6, they are indeed common to begin with. Perfect. Next step, we need to look at those two proper fractions to see if the first proper fraction is greater than the second proper fraction. And yes, 5 over 6 is indeed greater than 4 over 6. So if that's the case, we can go ahead now and subtract the whole number parts. So 4 subtract 2 is a 2. And then 5, 6 subtract 4, 6 gives us 1/6. So our answer, simplest form, 2 and 1/6. You will notice here that these examples have been strategically chosen. They will get harder as we go along, but we're starting off fairly straightforward. So in B, we have 1 and 5 sevenths, subtract 3 sevenths. We probably notice right away that there's no whole number portion in front of the 3 sevenths. That's because we don't have a complete whole. So we could look at that as being 0. That's fine. We focus on our proper fractions. We have 5 sevenths. We have 3 sevenths. Our denominators are the same again. Perfect. Now we compare the proper fractions, 5 sevenths and 3 sevenths. We notice again that 5 sevenths is indeed greater than 3 sevenths. If that's the case, we can subtract no problem. So 1 take away nothing is still 1. And if I go 5 sevenths, subtract 3 sevenths, I get 2 sevenths. And that is simplest form. In C, now this example is a step up, because when I look at my denominators for my proper fractions, I see that they're different. So the first step in our recipe is to get these two proper fractions that are associated with our mixed numbers. They must have the same denominator. So my LCD for 2 and 8 is 8. So I'm going to rewrite the 1/2. I keep my wholes the same. There are 5 wholes regardless. The 1/2, if I write the equivalent fraction for a half, I get 4/8. Subtract 3n. Well, this proper fraction already has a denominator of 8, so I just copy it down. Next step, look at those two proper fractions, 4/8, 3/8. We noticed, yep, the first one is greater than the second one. 4/8 is definitely bigger than 3/8. So we can subtract right away. 5 subtract 3 is 2. Then subtract the fraction parts. 4/8, take away 3/8. That's 1/8. So my final answer, and it is in simplest form, 2 1/8. In D, we look at our denominators of the proper fractions first. 3 and a 4. They're different. We need to get them the same. So what's the LCD for 3 and 4? Well, the LCD for 3 and 4 is 12. So I'm going to rewrite the first mixed number. I need to get the proper fraction with a denominator of 12. The second mixed number, I need to get the denominator of the proper fraction as a 12. So 2/3 is the same thing as what over 12? Well, 3 times 4 is 12. 2 times 4 is 8. 4 times what gives me 12? That's a times a 3. And a 1 times a 3 is 3. So now we've rewritten these two mixed numbers so that the proper fractions have the same denominator. And we do that so we can compare them, easily compare them. Again, we see that 8/12 is indeed greater than 3/12. So in our recipe, we're allowed now to go and subtract the whole number of parts right away. 8 subtract 5 is 3. And we can subtract those two proper fractions right away. And 8/12 subtract 3/12 gives us 5/12. So my answer, that is in simplest form, 3 5/12. So those are our situation A examples. Stay tuned to the next video. You know what's coming. Situation B. So please proceed to the next video in this lesson.